So, pseudo force, class 10th, if you are curious enough, you can go through this class to know more about centrifugal force, its origin. But let me tell you that this is not in your syllabus of board. But this is very important topic for class 11. So, class 11th, vector is in progress and Newton's laws of motion, that I am starting from today, and you have to go through this topic carefully with patience, understand each and every detail I am going to tell you. And we will talk in the first lecture about Newton's laws, because the whole story starts from the Newton's laws. Those things which you already know, like first law of Newton, you know that it's law of inertia, and every body resists the change of the state, and this property because of which matter resists the change of a state is called inertia. Actually, the story starts from second law, and interestingly it is just the extension of first law. Second law says that if net force acting on an object is 0, then acceleration of the object will be 0. What is acceleration? Acceleration is change of state. If a body is at rest, it starts moving. If a body is moving, its velocity changes. Either it accelerates or it deaccelerates, or it changes its direction. So, if there is change in state of a body visible, that is, acceleration of the body is not 0, then that means that net force acting on the body is not 0. No matter body is moving, but if it is moving with constant velocity, although it is moving, then also constant velocity indicates that acceleration of the state of motion or change of a state of motion is 0, and in that case, no matter how many forces are acting on the body, the net force acting on the body will be 0. But if acceleration is not 0, then no matter how many forces are acting, or even a single force is acting on the body, the net unbalanced force is there. So the story starts from here, but before I switch to the pseudo force, let me take one example of second law. If an object, a block, is pulled by force F towards right direction, right? And this surface is rough enough, so this surface will exert a frictional force opposite to the direction of motion. And say that our observation is that this object is moving with constant velocity. Constant velocity means neither its magnitude is changing nor its direction is changing. Constant velocity means net force acting on the body is 0, no matter there are two forces acting on the body in fact. So, if the block is moving with constant velocity, that means the acceleration of the body is 0. And if acceleration of the body is 0, certainly from the expression F is equal to ma, if acceleration is 0, that means net force is also 0. So let me see what is the net force acting on this block. The force F which is driving it in the direction of motion, and the frictional force which is opposing the motion. So obviously, since the two forces are acting opposite to each other, so the balanced force or the resultant force will be one force minus the other force. So the net force acting on the block will be F force minus frictional force. But net force is 0. So that means F minus frictional force is 0. And this implies that the force which is driving the object is exactly equal to frictional force, and that is why there is no acceleration of the velocity, no increase in velocity by the force F, or no decrease of velocity by the force friction, and the body is moving with a constant velocity. Tell me children, is this concept clear to you? Now the third law of motion, चलते चलते उसको भी देख लेते हैं. Simple, action force is equal to reaction force, and very important that action and reaction forces always act at two different objects. Let me see one example of action reaction law also, the third law. This law says that every action has equal and opposite reaction. Now I am taking an example of a table which is placed on the earth and a block is placed on the table. Now just check out, this block is pulled by the earth in downward direction. Yes or no? But the block is pulled by the gravity in downward direction. That will be shown in this way. If I draw this block till this point, let the block be of this size. Then the gravitational force, actually the forces are shown at the center of gravity. But I am showing this gravitational force because I don't want to miss the two vectors. So gravitational pull is acting on the block and is acting vertically downward. Now this is action done by the earth on the block. So where is the reaction? In some books also even the reaction is this one, the force exerted by the table on the block. No, earth is pulling the block down. So the block will pull the earth up. So the action is on the block and reaction is on the earth, because here the two parties which are interacting are block and earth. But if you want to know relation between block and table, then this block is pushing the table vertically downward because of its weight. And this block, since it is pushing the table down due to its weight, see, push of the block, and it is shown the vector starts from the table. So the object which is receiving this force is table, and this force vector starts from table vertically downward. So you have to pay attention how the vectors are drawn. And since block pushes the table down, the table pushes the block up. So the force which table exerts is shown by this vector in vertically upward direction, and that is shown on the block. So for the force of block on the table, this is the action. Reaction is normal reaction force of table on the block. But for the gravitational force on the block, the reaction force is force of block on the earth, which is shown, this vector is shown at the center of the earth. So this is something which I want to make it clear, that action reaction forces are very specified forces, and you cannot take any force in reaction of any other force which is not actually the action reaction pair. As I have given you the example of this whole case, even in some books it is written wrong. So all the three Newton's laws of motion we have discussed, and now we start with the pseudo force, a very interesting concept. Class 10th, centrifugal force is one pseudo force. But what is the origin of this centrifugal force? That you will understand in this video lecture. Pseudo force is a force whose source is not known. We cannot explain that from which contact or from which non-contact field this force originates. That is why it is called pseudo force or imaginary force. For example, take the example of a car. Mr. A suspend a pendulum from the roof of the car, and then he sits inside the car. He watches the simple pendulum, and he watches that simple pendulum is in vertically equilibrium position. He observes that gravity is pulling the bob down, but the thread is pulling the bob up with tension force, and the bob is in equilibrium. But suddenly car starts moving and it accelerates in the right direction. And Mr. A observes that pendulum is no longer in vertical position. Mr. A observes that bob shifts from its vertical equilibrium position like this if the car is moving in this direction. Acceleration of the car is towards right, then bob shifts towards left, as if some force pulled it or pushed it towards left. So, what should be the conclusion of Mr. A? That this bob is experiencing a force which we don't know from where that force is coming, but this happens only when the car accelerates. Even if the car is moving with a constant velocity, Mr. A observes if this car is moving with constant velocity, Mr. A observes that the pendulum is in vertical position. There is no change in the position of the pendulum. So, what should be the conclusion of Mr. A about this pseudo force? That this force comes into the picture only when the car is accelerating. If car is at rest, the pendulum is in vertical position. If car is moving with constant velocity, the pendulum is in vertical position, equilibrium position, and it comes into the picture only when car is accelerating towards the right. And one more observation, that whatever force is experienced by the bob, that force is just opposite to the acceleration of the car. So let me summarize the 2 points. That Mr. A observes that there is a force experienced by the bob. This is only when car is accelerating. Only when car is accelerating. Right? And the second observation Mr. A has, that this force is just opposite to acceleration of the car. Then he tries to understand actually what happened with the pendulum. If he accepts that there is a force acting on the pendulum which is not known to him, he also observes that the gravitational force and tension force which are already there, they have now their new orientation. The gravitational force always acts vertically downward, but tension force always acts along the length of the thread. So, unlike this situation, now the tension force is no longer vertically upward and it is at some angle. If the pendulum makes theta angle with the vertical, then tension force can be resolved in two directions, one which is T sin theta and other which is T cos theta. We know that the component which is having angle theta with the main force is the cos component, and we can easily understand that if this is theta, then alternate angle this will also be theta. Now Mr. A analyzes that T cos theta is actually balancing mg in this position, because now this is the new equilibrium position of the bob. This is not the case that bob keeps on moving towards the left. This is new equilibrium position of the bob. If the car is accelerating with acceleration a meter per second square, then this bob comes to this new position and here it is in equilibrium. So, Mr. A analyzes that certainly the T cos theta is balancing mg and the T sin theta is now busy to balance MA, which is trying to pull the bob in left direction just opposite to the acceleration of the car. And thus he says that T cos theta is equal to mg and T sin theta is equal to MA. These equations completely given the correct answer of all the quantities involved in this question. So Mr. A comes to conclusion that the force which was acting on the bob due to acceleration of the car is actually m into A, where m is mass of the bob and A is acceleration of the car. तो क्या समराइज करें बेटा कि क्या हुआ? मिस्टर ए कार में बैठे और उन्होंने एक पेंडुलम को कार की रूप से सस्पेंड कर दिया। पेंडुलम को उन्होंने ऑब्जर्व किया, उन्होंने एनालाइज किया कि दो फोर्सेस पेंडुलम पर एक्ट कर रहे हैं और क्योंकि पेंडुलम इक्विलिब्रियम में है, इसका मतलब कि जो वर्टिकली अपवर्ड फोर्स टेंशन है दैट इज कम्प्लीटली बैलेंस्ड बाय द वर्टिकली डाउनवर्ड फोर्स ग्रेविटेशनल फोर्स. Then suddenly car starts moving and it accelerates with acceleration a meter per second square towards right. And he observes that pendulum shifts from its vertical position. लेकिन वो ये भी देखते हैं कि पेंडुलम ऐसा लगता है जैसे किसी फोर्स ने पेंडुलम को इस डायरेक्शन में, लेफ्ट डायरेक्शन में फोर्स लगाकर धक्का दिया. पेंडुलम शिफ्ट हुआ, पर कुछ हुआ कि पेंडुलम इस नई पोजीशन पर आकर बैलेंस हो गया. तो मिस्टर ए ने दो कंक्लूजन्स निकाले. उन्होंने कहा कि यहाँ पर एक्सेलरेशन की वजह से देर मस्ट बी सम फोर्स विच इज एक्सपीरियंस्ड बाय द बॉब, एंड ऑल्सो ही सेड दैट दिस फोर्स हैज डायरेक्शन जस्ट ऑपोजिट टू द डायरेक्शन ऑफ एक्सेलरेशन ऑफ द कार। लेकिन सवाल अभी भी था कि ये जो फोर्स है, जो इसको नाम दिया स्यूडो फोर्स, ये फोर्स कितना लगा। तो मिस्टर ए ने पूरी डायनेमिक्स एनालाइज की। उन्होंने देखा कि बॉब पर कितने फोर्सेस एक्ट कर रहे हैं, 3, दिस स्यूडो फोर्स, ग्रेविटेशनल फोर्स एंड टेंशन फोर्स। इसमें से टेंशन फोर्स ही ऐसा था जो थीटा एंगल पर वर्टिकल से इंक्लाइन था। अगर टेंशन फोर्स को रिजॉल्व करें तो ये पता चलेगा कि क्योंकि बॉब इक्विलिब्रियम में है, neither it is moving towards left not right, so t sin theta must be equal to ma, and since it is not moving in upward or downward direction, so t cos theta must be equal to mg. So he wrote the equations, and the pseudo force he wrote as mass of the bob which is experiencing that pseudo force and acceleration of that environment, that is the car here, due to which this pseudo force arises. Mass of the object which is experiencing it and acceleration of the environment in whose acceleration gives rise to this pseudo force. And when he used these two equations and calculated the quantities, he found that the two equations are exactly correct. So he concluded that this pseudo force is having two properties. This pseudo force is having magnitude which is equal to mass of the bob into acceleration of that environment in which that bob is present and which is accelerating, and the direction of this force is just opposite to the acceleration of that environment which is car here. So Mr. A decided that he will observe few more events, examples, to know more about this pseudo force. And in the next video lecture we are going to analyze the second example of pseudo force. I hope that you got few points, and in second and third example we are going to understand this concept clearly.